Welcome to the class, dear students. This is the second class of Poisson distribution. In this lecture, I am going to do few more problems to understand Poisson distribution. Of course, we are going to find out the difference between Poisson and the binomial distributions by observing the questions what was asked. So now coming to the problem here, if a random variable x follows Poisson distribution, here it is given already, so such that this is the condition given. So find the mean variance and x greater than or equal to 1, what is the probability? For x equal to 3, what is the probability is asked you. So now first thing is, when you say p of x is equal to 1, is twice of p of x is equal to 2. So this is what given as the binomial, as the Poisson distribution. The condition he has given you. Now what is the formula for the Poisson distribution? As we know, that is p of x is equal to x given by e raised to minus lambda, lambda power x over x factorial. So now what was given, and p of x is equal to 1 is equal to twice of p of x is equal to 2 implies that means your e raised to minus lambda, x is 1, so lambda power 1 over x factorial, that means 1 factorial is given by 2 times of e raised to minus lambda, lambda power x is 2 now, so it is by 2 factorial, 2 factorial is 2. So this 2 gets cancelled, and therefore what it implies, e raised to minus lambda gets cancelled. So lambda is equal to lambda square implies lambda is equal to 1. Okay. So the mean is equal to 1. Okay. Now let us come to the second question. That is what he has asked. Okay, let us write down what is the mean now. Mean is equal to variance in the Poisson distribution, correct? And that is equal to lambda is equal to 1. Let us now go to the second question. That is p of x greater than or equal to 1. So what is p of x greater than or equal to 1? Let us see that now. That is 1 minus of p of x less than 1, correct? That is nothing but 1 minus of p of x less than 1 means x is 0. So what is this? 1 minus of e raised to minus lambda, lambda power 0 by 0 factorial. So what is this value? That is nothing but 1 minus of e raised to minus lambda, that is 1 minus of e power minus 1, because lambda is what? Lambda is 1, correct? Lambda is 1. So therefore the value of lambda is minus 1. And what is 1 minus e power minus 1 is given by, you can use the calculator, get the solution, which is 0.6321 is the solution. Now let us go to the third question. What's the third one now? Third one is p of x equal to 3. So p of x is equal to 3. X is equal to 3. So that is e raised to minus lambda, lambda power x over x factorial. So what are here now, what is lambda is 1 and x is equal to 3. Therefore it is e power minus 1, 1 power 3 over 3 factorial. So it is e raised to minus 1 by 3 factorial means 6. So what is this value? It is 0.0613. So this is what the solution for finding out the Poisson distribution. How to calculate in the Poisson distribution, what to do, all this we have done now in this problem. Let us now go to the next problem. Let us see here now the question here, read properly. Please be alert and pay attention, my dear students. Now suppose that the number of inquiries arriving at a certain interactive system follows Poisson distribution with arrival rate of 12 inquiries per minute. 12 inquiries per minute. That means on an average per minute they are getting 12 inquiries. Please pay attention when I am telling the word, I am pronouncing the word, that with arrival rate. Whenever arrival rate means what? It's nothing but the average. When I say average means what? It is the mean. When I say mean means what? In the Poisson distribution, it is lambda. So these are all we have to understand. Okay. Find the probability of 10 inquiries arriving. Suppose, then what is that? P of x equal to 10. Okay, understood? Then what is the expectation and variance of the number? Expectation means what? Mean. And variance of the number of arrivals. Both of them are the same. And that is already given, that is 12. During each of these intervals, that is given, that it is 12. So find the probability of 10 inquiries arriving. So that is what arrivals during each of these intervals. That is what given. Okay, let us now go to the problem now. So how to solve this now? Next. First of all, what is the mean? Mean is given by the expected value. Expected value is what? Lambda. And given that 12 inquiries per minute arrive at the rate of 12 inquiries. So you can understand that lambda equal to 12 is the mean. That means it is the average it is the average rate of 12 inquiries. What do you mean by that? Is this is the mean. Okay, lambda is equal to 12. Now lambda equal to 12. Now what is he said is the number of certain interactive arrival of 12 inquiries per minute. So find the probability of 10 inquiries arriving. What is the expectation in a 1 minute interval and in a 3 minute interval also? So the mean for 1 minute interval, that is for 1 minute. This is per 1 minute. Now per 1 minute 12. So for 3 minutes it is 36, right? So what you can say here is lambda equal to 12 into 3. This is the mean per 3 minutes. Okay. So that gives you lambda is equal to 36 per 3 minutes. Lambda equal to 12 per 1 minute. Okay. Now, so we know now what is the mean. Okay. Now coming to the variance part. What is the variance in Poisson distribution? Mean is equal to lambda. So it is equal to 36. 12 for 1 minute mean, and variance is also 36 minutes. Okay, that is over. Mean is equal to 12 per minute, and the variance to lambda equal to 36 per 3 minutes. Okay, so first question is done. Now in a 1 minute interval, what is the probability of getting 10 inquiries? So what is x here? 10. So what is the first one? Probability distribution function is what? E raised to minus lambda power x over x factorial. Now we need probability of x equal to 10 inquiries. So it is e raised to minus, now it is for 1 minute, it is asked at the second question, per 1 minute. So our mean is what? Mean is lambda is what? 12. And lambda is 12 power x is 10 over 10 factorial. So this is what the answer. So what is this? Given by 0.1048 is the answer for this question. Now coming to the same thing in a 3 minute interval, what is it? So in a 3 minute interval, what is the probability of x is equal to 10 in a 3 minute interval? So e raised to, so we can write that in a 3 minute interval, the mean lambda is equal to 36. Okay, so let us now do the problem. E power minus 36 into 36 to the power of 10 over, it is 10 factorial. So this is what we are going to do now. So what is this? This is given by 2.337 into 10 to the power of minus 7. This is what the solution. I hope you could understand how to do this type of the problems by using the Poisson distribution. Very simple problems these are. Now, it has been established that the number of defective stereos produced daily at a certain plant is Poisson distributed with mean is equal to 4. What is given? Direct question. Lambda is given. And what is the probability that the number of stereos does not exceed 3? Does not exceed 3 means does not be more than 3. That means it is less than or equal to 3. That is what the understanding. So let us now take whatever everything. So what is that? Mean is equal to here what? Mean is equal to, with the mean given already, is what? Lambda is equal to 4. Probability that the stereo does not exceed 3 means x is less than or equal to 3. Does not exceed 3 means x is less than or equal to 3. So now what is meant by less than or equal to 3? When x is 0, when x is 1, when x is 2, when x is 3. X is 2 and x is equal to 3. So this is what we get. So now when you say p of x is equal to 0, suppose, then it is e raised to minus lambda, lambda power 0 by 0 factorial, plus e raised to minus lambda, lambda power 1 by 1 factorial, plus e raised to minus lambda, lambda square by 2 factorial, e raised to minus lambda, lambda cube by 3 factorial. Now what is lambda here? 4. So e power minus 4 into 4 power 0 by 0 factorial is 1. I'm sorry, minus lambda you should replace by minus 4, correct? E raised to minus 4. Again e raised to minus 4 times of 4 power 1 by 1 factorial. E raised to minus 4 times of 4 square by 2 factorial. E raised to minus 4 times of 4 cube by 3 factorial, which is 6. So let us add up all this, what we get. You can use the calculator, and to get the solution it is 0.4335. This is what the answer. Okay. These are all the direct questions actually. Now let us go to the next question. Assume that the number of hits on a certain website during a fixed time of interval follows a Poisson distribution. So assume that the mean rate of hits is 5 per minute. So what do you mean by mean rate? Means lambda is equal to 5, already given. Now find the probability that there will be exactly 17 hits. So x is 17 and then lambda is 5. Is these two already given? So direct formula application, that's it. So what is given is lambda is 5 and x is equal to 17. So what is the probability of x is equal to 17? E raised to minus lambda, lambda power x over x factorial. That is given by e raised to minus 17, 17 to the power of 5 over 5 factorial. So what is this now? It is x is 17, right? Lambda equal to 17, exactly 17 hits. So it is e raised to, I'm sorry, this is minus, lambda is 5, right? So it is, so this type of mistakes we have to avoid, may happen also. E raised to minus lambda, formula is power minus e raised to minus lambda times of lambda power x by x factorial. That is e raised to minus 5 times of 5 power 17 time over 17 factorial. So do the calculation. It will be 0.0847. This is the answer. Direct question it is. Let us go to the next problem. On the average, 2 tornadoes hit the major US metropolitan areas every year. So on an average of 2, this question, this, what is this? Mean is equal to 2. Lambda is equal to 2. Now what is the probability that more than 5 tornadoes, that means P of X greater than 5 occur in the areas next year. So we have to find out that now. Direct question again, right? So now what is it now? What is the average? Average is what? Lambda. Lambda is what? Mean. Mean is given as 2. And P of X is equal to X is given by e raised to minus lambda, lambda power X over X factorial. So what is this? P of now has asked you more than 5 tornadoes. That means X is what? Greater than 5. When P of X is greater than 5, we have to find out the solution. Greater than 5 means instead of that what we do? P of X less than or equal to 5 we find out and subtract from 1. So what it gives us, let us see now. So we write down the equation properly. It is 1 minus P of X is equal to 0 plus P of X is equal to 1 plus P of X is equal to 2, X equal to 3, X equal to 4, X equal to 5. So these are the things you have. Okay. And now what is P of 1 minus of P of X equal to 0? That means what? E raised to, already we know what is lambda, minus 2. Lambda means 2, 2 power 0 over 0 factorial plus e raised to minus 2, 2 power 1 over 1. E raised to minus 2, 2 square over 2 factorial. E raised to minus 3 is minus 2. 2 raised 2 power 3 over 3 factorial. E raised to minus 2, 2 power 4, 4 factorial. E raised to minus 2, 2 power 5, 5 factorial. That is what the solution. So when you do all that, do the calculations, then it will be 0.0165. This is the answer. Okay, direct all this now. Now coming to the proof of, if there are if there are 20 typographical errors randomly distributed in a 250 page document, what is the probability that a given page contains exactly 2 errors? Exactly 2 errors. So here first of all it is not given. What is not given? Which distribution you have to use is not given, like the previous problems. Okay. So first thing, when there are 250 pages, that means it is very much clear that n is 250. When such a big number is there means you can understand that is Poisson. Why it is discrete now? There are 2 errors, like that it was the question. So discrete values are given and n is more. So you can identify that it is the Poisson distribution. So now what is the x here is the errors. Getting errors is the probability, that is the probability of the success, that is P. Okay. And what is n here? It is given that 250. And 20 typographical errors. So what is P? P is given by, out of 250 you are there are 20 errors. So 20 over 250. So therefore now you can find out the mean. What is mean formula? Lambda is equal to n into P. So it is 250 times of 20 by 250. So that lambda value is 20. Clear? So lambda value we got it as 20. So now the formula P of X is equal to X is given by e raised to minus lambda, lambda power X over X factorial. So what is P of X is equal to? Now the question is what? The given exactly 2 errors. So it is given that exactly 2 errors he has asked you. So you know that lambda is 20 and we know that X is 2, so 20 square over 2 factorial means 2. So now what is this value is given by 4.122 into 10 to the power of minus 7. So this is what the solution. Okay. So with this we have done with all the Poisson distributions. I hope you could understand when we use the Poisson distribution, when we use the binomial distribution. consistently whenever you have there is a considerably bigger number of trials or in the experiment the number of the number of trials is a bigger number, then you can say that it is a Poisson distribution. I hope it's clear. And when the number is big, when the number of trials are big, are getting big, then definitely the success gets very less. So that is what you should understand in Poisson distributions. Please try to understand one thing. What is the comparison when we are doing the distributions, we have to compare between the both. So this is what very important to understand, where we are using binomial, where we are using the Poisson, and what are the differences. Please understand that, then you will understand very clearly where to use binomial and where to use the Poisson distributions. I hope it is very much clear. Thank you.